Hello grade 11s. Today I'm looking at page 82 of your workbooks, an example of a curve of interpenetration and development. Definitely more advanced here. This drawing has got a hexagonal main pipe which has been tilted at 15 degrees and a square branch pipe, and you need to work out obviously the curve of interpenetration, and then they've asked you just to develop the surface of the branch pipe. So let's get started by drawing the hexagon that is tilted at an angle of 15 degrees in the top view, and then working towards the front view and the curve of interpenetration. So there I've projected my center line at the angle required. Remember, if you're unsure, just check by lining up with your views over here to see what angles you needed. So there was the vertical line through the center of my hexagon, and I'm now going to do my 15-degree line. There's my 15-degree line, and now I'm going to draw my circle with a radius of 32, which is the length of the side of the hexagon. I have completed my hexagon, and I've done a construction of the square duct just so that I could get the measurements to project back here into my top view. I'm just going to save some time and draw them in dark straight away. So I've got my completed top view. From this we're going to project our lines up to get our front view. I've projected my lines up from the top view into the front view, and I've gone over lines that I don't feel are going to be affected, and the edges here with the hidden detail. Now they tell us that the height of our branch pipe is protruding at a height of 34. There is the center point for where the branch pipe sticks out. And what I'm going to do is also just put my auxiliary view over there. Now the advantage of having this being drawn here, what I can do is take my points up. Now with my compass measure the points of my branch pipe and mark them off. Don't really need the side. And there we can have our auxiliary view drawn in the front view as well. And take the height measurements across. I'm going to do some numbering now on the drawing. If you want lettering. So point A and D, we need to remember that once we've done this in our front view, looking from the front view to the top view is a rotation of 90 degrees. So when we label in our top view, we've got to rotate 90 degrees. And rotate with the same direction that you've numbered or lettered. So I've gone clockwise, so I've rotated clockwise when I've labeled. This would mean that this gives me point A and C. This gives me point B. This gives me point D. Let's go and find where those points are now in our front view. I'm following my process of the theory of 2 points. And what I'm going to do in a logical approach is work from the bottom point that I can see in my top view to my highest point in the top view. So my first point is B. So for my theory of 2 points, I need 2 points. B here is my horizontal B point, and from my top view I now need to take my vertical B point. Where they intersect, that gives me point B. I've got a turning point here which we're going to have to calculate later. Now I've got points A and C. Once again, A is at the top of the shape, C is at the bottom of the shape. There are the 1 points from that side. Now I need my vertical point from this side, and I project it up to hit and give me point A and point C. This is a turning point here on the edge. We're also going to have to find out where that is. And next we're going to find point D. So here's point D. This is where D is in the top view, and we've projected that up, and that gives me point D. So there are our basic points, A, B, C, and D of our shape. The problem we have is that at certain points they are cut by the turning points at these two edges. We now need to calculate where those are. I'm going to calculate turning point 1. Turning point 1 is at this point. Now how do we find out where that is going to be to get our height measurement? The key here is we're going to have to use our auxiliary view. So what we do is we take this line and we project it through to hit on our auxiliary view. Now I like to take a bigger measurement with my compass. So what I'm going to do is I'm going to take the measurement from our turning point to the corner. So I'm taking the distance from C to B, and it will be the same distance from A to the turning point. So what I'm going to do is put my compass at C and mark towards B, and I'm going to do the same at A marking towards B. So this is going to give me this small turning point over here. As you'll notice, that is the same distance over there. So now for turning point 1, we've now got the heights calculated, so we can project them. Okay, so this is our turning point height. Now we need the turning point on the vertical line, okay, to find our second points. And I project that up, and where those intersect, here is where I'm going to have this turning point and this turning point. Let's follow the same process to find the next turning point. Here is the next turning point. So my process was to project it into the auxiliary view. Take that measurement in the auxiliary view. So either way, you can take the distance from A to where the turning point is, or you could have measured from D. Now if I measure from A, I have to measure from C on the other side. Do the same thing. So there I measure from C back towards D, and on the other side I measure from A going towards D. So these were the turning points in the auxiliary view on that side. Here are the turning points in the front view. Now let's follow the theory of 2 points. Let's project our turning point. Project our turning point. And where that's going to hit this edge, is going to be those turning points. So let's join up our different points now. Adding to this difficulty of the drawing, what we need to understand is that point A and C is the highest point of our branch pipe. So this turning point and point D will be behind that, which means that they will be in hidden detail. So what I'm going to do now is go from point B to the turning point to the highest point as a visible line, outline, dark line. Then go on to the hidden detail. Let's work out this shape now. Try and work in a logical process, so either work from the inside to the outside or from the outside to the inside. That's your choice. I'll do from the inside to the outside for this bottom part. So the first point I had to follow was point B. The next point it hit was the turning point. So there is point B and point turning point. I would join that line up. The turning point then goes to C at the bottom of the shape. So there's my turning point to C at the bottom of my shape. So that is the bottom part of my shape. Now I'm going to do the top part of the shape, and I'm going to work from the inside out. So the point on this side was point A. So there is point A. A goes from there to the turning point. So let's join up A to this turning point. The turning point then joins to point B. And you've got a mirrored shape there. Next, so this is going to be in hidden detail. I've got A going to the next turning point. So A goes to the next turning point in hidden detail. From the turning point, it goes to point D in hidden detail. From point D, it's going to go to the turning point. And then from the turning point to point C in hidden detail. There are my shapes, and now let's finish off the outline. There is our shape. Quite interesting. This is the edge here going down to the turning point. That's why that little piece is hidden detail. Same on the other side, from the bottom edge to where it touches at the end of this corner. Here is this line going up to the turning point, and the same for this corner. Next, they've asked us to develop the square prism. What I'm going to do is take our shape, turn it, and draw it in the space down at the bottom here. I've marked off the length of my square prism as the branch pipe. It was a length of 38 for those 4 different components. Now, with this drawing, because the branch pipe fits in horizontally, the lengths that you're going to take will be the same in the top view as well as the front view. So that's quite lucky, and an advantage when your branch pipe is parallel with the base of your shape. You can take the length measurements on either the front view or the top view. So let's find those length measurements. Our first point is point A. So here is point A. And we're going to take that measurement with my compass. Remember, you can take a paper trammel as well if you wanted. There's my distance for point A and point C. So I'm going to mark that off at points A, C and A. Next point is point B. And this would be a nice thing just for you to check. So if I take that distance B, is that the same distance over there? So that way we know that there's no changes. If they were different, and that would be a case if the branch pipe was tilted, there would definitely be a difference in measurement. Go to point B, mark that height off. Last point of the main edges was point D. So I take my distance at D and transfer that to my development. Do we have some other points? Yes, we do. We've got our turning point heights. Now remember, we can't take a measurement off the same drawing. So to find where our turning points are, we need to go to our auxiliary view. So here is our auxiliary view, and I'm going to take the measurement from B to the turning point here. I hate small measurements with my compass. I'm going to go to point B. Then what I need to do is mark on both sides of point B for these turning points. I'm going to find the turning point on the other side. So from A going towards point D. Follow that up, go to your development at A, mark that off. Now that would be the same as C going to D. So I go to point C and mark that off at D. I'm now going to draw in my vertical lines. The measurement that I need at this turning point, so let's come and take this measurement from that turning point to the front edge. I'm going to mark that off. I'm then going to go to my next turning point, get that measurement and transfer that. That now gives me all the points that I need to join up my shape. There you have the completed development for drawing number 82. Remember that because we have got straight lines or straight edges in both shapes, the lines joining up will be straight. At the folds, so at A, B, C, D and back at A, we've got solid lines to indicate the corners of the shape.